See, in the last two videos, we have proved the formulas to find out angle between two planes, angle between line and plane, condition for coplanarity of two lines, and distance of a point from the plane. So try to go through last two videos so that you are able to apply those formulas to solve the example from this exercise. So see, in the question number first, we have to find out angle between two planes. If you'll observe the angle between two planes, both the equations are in what? Vector form. And if two equations are in vector form, at that time which formula is applicable to find out angle between two planes? Cos theta is equal to n1 bar dot n2 bar divided by magnitude of n1 bar into magnitude of n2 bar. Means to apply this formula, we will require the value of n1 bar and n2 bar. These values can be find out from the equation of two plane. Means equation of first plane is in the form of r bar dot n1 bar is equals to P, and second equation is in the form of r bar dot n2 bar is equals to P. So here we can say that from this equation n1 bar is equals to, what is the value of n1 bar? I cap plus j cap plus 2k cap, and value of n2 bar is equals to 2i cap minus j cap plus k cap. Once the equations from these two equations, once the value of n1 bar and n2 bar is known to us, then apply this formula to find out angle between two planes. So I am denoting here angle between two planes by theta. Let theta be the angle between two planes. So therefore cos theta is equals to, what is the formula? n1 bar dot n2 bar divided by magnitude of n1 bar into magnitude of n2 bar. So which is equal to, now we are substituting value of n1 bar. What is the value of n1 bar here? I cap plus j cap plus 2k cap. Keep this dot as it is, replace n2 bar by its value, where its value is equal to 2i cap minus j cap plus k cap. In the denominator, magnitude of n1 bar. So this is n1 bar, so its magnitude is 1 square plus 1 square plus 2 square. And magnitude of n2 bar. Now we are finding magnitude of n2 bar. Its value is given to us. So 2 square plus minus 1 square plus 1 square. 2 square plus minus 1 square plus 1 square. Remaining part is just to simplify it. So which is equals to, so here we are finding value of cos theta. So in the numerator we are finding dot product of these two vectors. So both the vectors are in Cartesian form. So here their dot product 2 into 1 will be equals to 2. Minus 1 into 1 is minus 1, and 1 into 2 is 2. Means what we are getting? 2 minus 1 and what? Plus 2. In the denominator, what we are getting in the root? 4 plus 1 means we will get 6. So root 6. In the second root, let us see what we will get here. So 4 plus 1 means here also we are getting 6. So in the numerator, 2 plus 2 is 4, 4 minus 1 is 3, and in the denominator, root 6 into root 6 is 6. See what we are getting here. So 3 by 6 means 1 by 2, and mod of 1 by 2 is 1 by 2. So cos theta is 1 by 2. It implies that theta is equals to how much degrees? So when the value of cos theta is 1 by 2, if theta is how much? 60 degree. That's why we can say that angle between two planes is equals to 60 degree. So therefore angle between two planes is 60 degree. In this way we have got our required value, angle between given two planes. Now in question number 2, we are finding the acute angle between this line and the plane. So equation of line is also in vector form. So we know that equation of line in vector form can be written as r bar dot a bar plus lambda b bar. And equation of plane is also in vector form. It is in the form of r bar dot n bar is equals to p. Okay. When both the equation of line and plane are in vector form, at that time we have seen one formula to find out acute angle between them. Let us denote this acute angle say by theta. Let theta be the acute angle between line and plane. So if theta is the acute angle between line and plane, so therefore cos theta is equals to, what is the formula of cos theta? Sin theta is equals to, we have proved a formula to find out acute angle between line and plane. Sin theta is equal to b bar dot n bar divided by magnitude of b bar into magnitude of n bar. Applying this formula, we are able to find out angle between line and the plane. To apply this formula, we will require the value of b bar and what? N bar. So from the given equation, let us try to find out value of b bar and n bar. So here we can say that b bar will be equals to, now this equation is in the form of r bar is equal to a bar, r bar is equals to a bar plus lambda b bar. So from this equation, b bar is equal to 2i cap plus 3j cap minus 6k cap. Okay, and from the equation of plane we will get the value of n bar, because this equation is in the form of r bar dot n bar is equals to p. So what is the value of n bar here? 2i cap minus j cap plus k cap. Once these values are known to us, just substitute these values in this formula. So which is equals to, I am replacing b bar by its value, that is 2i cap plus 3j cap minus 6k cap. Dot, keep it as it is, then substitute the value of n bar, that is 2i cap minus j cap plus k cap. Okay, in the denominator, magnitude of this b bar is equals to under root 2 square plus 3 square plus minus 6 square. Then find out magnitude of n bar. This is the value of n bar. So here we will get 2 square plus minus 1 square plus 1 square. Once the values are substituted, so remaining part is simplification part. In the numerator, we are taking dot product of these two vectors. As is stand, they are in the Cartesian form. So first take the product of coefficient of i cap, that is 2 into 2 is 4. Then take the product of coefficient of j cap, that is 3 into minus 1 is minus 3. And minus 6 into 1 will be equals to minus 6. In the denominator, let us simplify it. Here we will get 36 plus 4, 40, 40 plus 9 is 49. And what is under root 49? 7. And here we will get 4 plus 1 means we will get root 6. So which is equals to, see what we are getting here. So 4 minus 9 will be equals to minus 5, and in the denominator 7 root 6, keep it as it is. Now if we are taking value outside the mod, so it will become 5 upon 7 root 6, and this is the value of what? Sin theta. So which implies that theta is equals to sine inverse of what? 5 upon 7 root 6. In this way, we have got the value of what? Theta here. So therefore, we can say that angle between line and plane is how much? Sine inverse of 5 upon 7 root 6. So in this way, we have got the angle between this line and this plane. Now see in the question number 3, equation of two lines are given to us. In the first part, we have to show that these two lines are what? Coplanar. And once if we are able to show that the lines are coplanar, then we have to find out the equation of plane determined by them, means equation of plane determined by these two lines. So first let us discuss how to show that two lines are coplanar. So now equation of two lines are given to us, and if you will observe the equations are in what? Vector form. If equations are in vector form, at that time we have proved one condition to show that two lines are what? Perpendicular. So if we are able to show that box product of A2 bar minus A1 bar, B1 bar and B2 bar is equals to what? 0. If the value of this box product will be equals to 0, we can say that two lines are what? Perpendicular. Sorry, two lines are what? Coplanar. So let us, to apply this condition, we will require the value of A2 bar, then what, A1 bar, B1 bar, and what, B2 bar. First, let us try to find out these values from this equation. So here, from the equation number first, equation first is in the form of R bar is equals to A1 bar plus lambda B1 bar. So what is the value of A1 bar here? A1 bar is equal to 2j cap minus 3k cap, and value of B1 bar will be equals to I cap plus 2j cap plus 3k cap. Then value of A2 bar is equals to here 2i cap plus 6j cap plus 3k cap. Okay, and B2 bar, value of B2 bar is equal to 2i cap plus 3j cap plus 4k cap. All these values we are getting from the equation of two planes. Once these values are known to us, here which value is required? First required value is A2 bar minus A1 bar. So this implies that A2 bar minus A1 bar is equals to. Now we are taking subtraction of these two vectors. Substitute the value of A2 bar, that is 2i cap plus 6j cap plus 3k cap minus value of what? A1 bar. A1 bar is equal to 2j cap minus 3k cap. Just simply we are taking subtraction of these two vectors. See what we'll get here. Term of I cap is 2 and here term of I cap is missing. Means 2i cap minus 0i cap will be equals to 2i cap. Then collect the terms of j cap. 6j minus 2j will be equals to 4j. Lastly, collect the terms of k cap. 3k cap minus means plus 3k cap. 3 plus 3 will be equals to what? 6k cap. Once the value of A2 bar minus A1 bar is known to us, now we have to check that. Now we are finding value of this box product, and we have to check that the value of box product is 0 or not. If we are able to show that value of this box product is 0, then this is nothing but condition for what? Coplanarity of two lines. Means we can say that the given lines are what? Coplanar. So which is equals to, value of box product can be find out using what? Determinant. In the first row, write down the coefficient from first vector. What are the coefficients here? 2, 4, 6. Then write down the coefficients from second vector, means B1 bar. So that is 1, 2, 3. And lastly, write down the coefficient from B2 bar, because next vector is B2 bar. What are the coefficient? 2, 3, 4. Let us simplify this determinant. So which is equal to, keep this 2 as it is, delete this column, find out determinant of these 4 element. 8 minus 9 will be equals to minus 1. Here plus 4 is there, so write down here minus 4, delete this column. So this product is 4. 4 minus 6 is minus 2, and here plus 6, keep it as it is, delete this column. 3 minus 4 will be equals to what? Minus 1. So check what result we are getting. 2 into minus 1 is minus 2. Minus 4 into minus 2 will be equals to plus 8, and 6 into minus 1 will be equals to minus 6. So here we can observe that minus 6 minus 2 will be minus 8, minus 8 plus 8 will be equals to 0. Since we have shown that value of this box product is 0, so we can say that, so therefore given lines are coplanar. Okay, once we have shown that the given two lines are coplanar, now second part is to find out equation of plane determined by them. So we have already written one formula to find out equation of plane determined by what? Determined by these two lines. What is that formula? And vector equation of plane is, what is the vector equation? R bar dot B1 bar cross B2 bar is equals to A1 bar dot B1 bar cross B2 bar. Applying this formula, we are finding equation of plane containing these two lines. Okay, but to apply this formula, which value is required? B1 bar cross B2 bar. So let us first try to find out value of B1 bar cross B2 bar. So better we find out this value here. So value of B1 bar cross B2 bar will be equals to, we know that cross product can be find out using what? Determinant. So So already we have got here value of a1 bar, a2 bar, b1 bar, b2 bar. So this value is required to show that these lines are what? Coplanar. And b1 bar cross b2 bar, this value is required to find out equation of plane. Better way here only find out this value. So what are the coefficients in b1 bar? 1, 2, 3. In b2 bar 2, 3, 4. So which is equal to, first we are trying to find out coefficient of I cap. So delete this column. So 8 minus 9 will be equals to minus 1. Here plus j cap is there, so take here minus j cap. Delete this column. So 4 minus 6 will be equals to minus 2. Minus and minus will become plus 2. Lastly find out coefficient of k cap. Delete this column. This product is 3. 3 minus 4 is minus 1. So minus, if you are not writing 1 means it is considerable that 1 is there, isn't it? Once the value of b1 bar cross b2 bar is known to us, remaining part is just to substitute the values in this formula. So what we'll get here, r bar dot b1 bar cross b2 bar, its value is equal to minus I cap plus 2j cap minus k cap. Okay, on this side a1 bar, what is the value of a1 bar here? 2j cap minus 3k cap. Keep this dot as it is. Now substitute the value of b1 bar cross b2 bar, that is minus I cap plus 2j cap minus k cap. So simplify this side. So here 2 into minus 1 is minus 2. Then minus 3 into 2 is minus 6. Simply we are taking dot product of these two vectors. Here coefficient, this is term of what? J cap, means term of I cap is missing here, means here 0 I cap is there, means 0 into minus 1 is 0. Then take the product of coefficient of J cap, that is 2 2s are 4. And here minus 3 into minus 1 will be equals to plus 3. Means on this side we will get 7. Keep this side as it is, r bar dot minus I cap plus 2j cap minus k cap. In this way we have got required vector equation of required plane. So now we are solving question number 4. In this question number 4 we have to find out distance of the point from this plane. Okay, so already we have proved one formula to find out distance of a point from the plane. So what is the distance of the point from the plane? Is p minus a bar dot n cap. Means here a bar, value of a bar is already given to us. But to apply this formula we will require p and what? N cap. P means what? Distance of the plane from the origin, and n cap is a unit vector along the normal. To find out these values, this equation of plane, we have to convert it into what? Normal form. As it stands, when equation of plane is given to us, we have to convert it in the normal form. Once the equation is in normal form, we will get the value of p and what? N cap. And substituting this value in this formula, we will get the distance of the point from the plane. So first let us try to convert this equation in what? Normal form. Again, another formula is also there. So to find out distance of a point from the plane, that is nothing but the distance is equals to a bar dot n bar minus p divided by magnitude of n bar. Applying this formula also we are able to find out distance of a point from the plane. Here a bar is nothing but position vector of the given point. N bar, here we will get the value of n bar from the equation of plane, and this is the value of what? P, and in the denominator we will require magnitude of this n bar. But this formula is now as it stand, in this case instead of giving this formula in the textbook, this formula is given, so that's why I am giving priority to apply this formula. So but you will have a choice, you are able to apply this formula also or this formula also to find out distance of a point from the plane. I am just giving priority because this formula is given in what? Textbook. This formula is not given in the textbook, so that's why I am giving priority to apply this formula. So now we are converting this equation in what? Normal form. So here to convert it into normal form, so we have to convert this vector into what? Unit vector. So to convert it into unit vector, we have to divide to this vector by its magnitude. So let us denote this vector by n bar is equals to 2i cap plus 3j cap minus 6k cap. So therefore magnitude of n bar is equals to, so 2 square plus 3 square plus minus 6 square, so which is equals to under root 4 plus 9 plus 36, which is equals to under root 49, so which is equals to what? 7. So I am dividing to equation number first both side by 7. Let us see what we'll get. So divide both sides of equation first by 7, we get. Let us see what we will get if we are dividing both sides of this equation by 7. So observe this equation, r bar dot 2i cap plus 3j cap minus 6k cap is equals to, so I am dividing to this side by what? 7. So here we will get divided by 7, and on this side if I am dividing by 7 we will get 3. Once the equation is in normal form, so we are able to find out value of n cap and p. Now this equation is in what? Normal form, because we are dividing to this n bar by its magnitude. Magnitude is what? 7. If we are dividing to this vector by its magnitude, means we are converting it into what? Unit vector. So this implies that n cap is equals to, what is the value of n cap here? 2i cap plus 3j cap minus 6k cap divided by what? 7. And what is the value of p here? And p is equal to what? 3. Once these two values are known to us, remaining part is just to substitute these values in this formula. So I am replacing p by what? 3 minus a bar. What is the value of a bar here? 4i cap minus 3j cap plus k cap dot n cap. What is the value of n cap here? 2i cap plus 3j cap minus 6k cap divided by what? 7. Okay, so which is equals to, keep this 3 as it is, in the denominator 7 also keep it as it is. Just we are finding dot product of these two vectors. 4 2s are 8. So already we know that how to find out the dot product if vectors are in Cartesian form. First take the product of coefficient of I cap, then product of coefficient of j cap is minus 9 here, and product of coefficient of k cap, that is 1 into minus 6, will be equals to minus 6. So which is equal to, keep this 3 as it is, minus also as it is, 8 minus 9 is minus 1, minus 1 minus 6 is minus 7 upon 7. So which is equal to 3 minus 1, and minus into minus will become plus 1, means will be equals to 4 units. So in this way we have got the distance of this point from this plane, and this is the value which we have to find out here. Well, this is the last example from this exercise. In the next video we are starting miscellaneous exercise. If you really like these videos, so please share these videos with your friends. Write down your comment in the comment box, and please subscribe the channel. Now see, in this question we have to find out distance of this point from this plane. Okay, one point is given to us and one plane is given to us, and we have this formula to find out distance of a point from the plane. Sorry, this is the last example. Okay, so we have to find out distance of this point from this plane, and this formula is applicable. This formula is applicable if the equation of plane is in what? Vector form. We have one formula to find out distance of the point from the plane in Cartesian form, but that formula is not given in the textbook. So that's why we are giving priority to apply this formula, but you should have to know that formula also. Suppose that if equation of plane is in the form of ax plus by plus cz plus d is equal to 0. So in the numerator write down same equation, ax plus by plus cz plus d. and here replace this x by x coordinate. If I am denoting x coordinate by x1, y coordinate by y1 and z coordinate by what? z1, divided by under root a square plus b square plus c square. So very easily, in very easy way, we are applying this formula, we are able to find out distance of a point from the plane. But why I am giving priority to apply this formula? Because this formula is not given in the textbook. Okay. So well, for that purpose, means to apply this formula, first the equation of plane should be in what? Vector form. So I am converting this equation in vector form. So therefore vector equation of plane is, just simply convert it in vector form. So vector form is r bar dot n bar. N bar, these 3, 4, minus 12 are nothing but what? Direction ratios of the normal. And from these direction ratios of the normal, we can say that vector along the normal is 3i cap plus 4j cap minus 12k cap. And this plus 20 on this side will become minus 20 is equals to minus 20. In this way, we have got vector equation of plane. So value of n bar is also known to us. So here n bar is equals to, what is the value of n bar? 3i cap plus 4j cap minus 12k cap is equals to minus 20. Keep it as it is. Let us denote this equation by equation number first. So this implies that magnitude of n bar, because we want the value of what? N cap. So that's why we have to find out unit vector. So here we will get 3 square plus 4 square plus minus 12 square. So which is equal to under root. What is square of 12? It is 144 plus 16 plus 9 will be equals to what? 169, and square root of 169 will be equals to 13. So magnitude of n bar is also known to us. To convert this equation in normal form, I am just simply dividing both sides of this, denote this by equation number first. I am dividing both sides of this equation first by what? 13. So divide both sides of equation first by 13. Okay, so let us see what we'll get here. R bar dot, keep this 3i cap plus 4j cap minus 12k cap as it is, on this side minus 20 also as it is. Just simply I am dividing both sides by 13. Now we can say that this equation is in what? Normal form. So once the equation in normal form is known to us, we will get the value of n cap and what? P. So we can say that therefore n cap is equals to, so therefore n cap is equals to, what is the value of n cap here? 3i cap plus 4j cap minus 12k cap divided by 13, and P will be equals to, what is the value of P here? Minus 20 upon 13. Once all these values are known to us, remaining part is just to substitute these values in this formula. So what is A bar here? A bar, or we can say that distance of the point A having position vector. What is this position vector? I cap plus j cap minus k cap. One point is given to us. From this point we have got the value of its position vector. So now distance of this point from the plane. What is the equation of plane here? 3x plus 4y minus 12z plus 20 is equal to 0 is equals to. So substitute the value of P. P is equals to minus 20 upon 13 minus A bar dot n cap. This is the value of A bar. That is I cap plus j cap minus k cap dot n cap. What is the value of n cap here? 3i cap plus 4j cap minus 12k cap, okay, divided by 13. So which is equals to, keep this minus 20 upon 13 as it is, minus also as it is. Just simply we are taking dot product of these two vectors. So observe here dot product. So 3 into 1 is 3, 4 into 1 is 4, and minus 1 into minus 12 will be equals to plus 12. So which is equal to minus 20, keep it as it is, divided by 13 also as it is, and here also 13, keep it as it is. 12 plus 4 is 16, 16 plus 3 is 19. So since the denominators are same, so take the addition of numerator. So minus 20 minus 9 will be minus 39. So minus, keep it as it is, 39 upon 13 will be equals to 3. So mod of 3 will be equals to what? Mod of minus 3 will be equals to 3. So in this way, 3 units will be the distance of the given point from this plane. So even if we are applying this formula, so we are able to avoid some steps, isn't it? But again, see, this formula definitely we are applying while solving objective type questions. But as is trend, this formula is not given in our syllabus, and that's why I am applying this formula, which is in the vector form. Some steps are definitely increasing here, and if we are applying this formula, hardly within 3 or 4 steps we will get our required distance of the point from the plane. Well, in this way we have completed this exercise. In the next video we are starting miscellaneous exercise. I think it is second miscellaneous exercise from this chapter.